welcome to Physics 3.1 on types of forces. So how do you know, this is after we've done the lab, how do you know a force has occurred? Well, there are two ways. One is when a force is applied to an object, its shape might change. That's called a deformation. And you saw that a little bit in the lab that you did. The other way that a force has occurred, or you can tell a force has occurred, is when the motion changes. It might move, it might stop, it might change direction. That way you know a force has occurred. There are two general categories of forces. Contact forces, those that require your object to be in direct contact with it, whatever is causing that force, pushing, pulling, squeezing, friction. And then you have field forces. Field forces are those that act at a distance, like gravity, magnetism, and electricity. So on the left are contact forces, and on the right are field forces. Just little picture examples. There are four forces of nature, and on the macroscopic level, we will observe several forces, right? Macroscopic meaning big enough to feel, see, touch. Those are gravity and friction, elasticity, magnetism, and you saw a lot of these in the lab. The origins of all of the forces, though, can be traced back to four fundamental forces of nature: gravity, electromagnetic, strong, and weak. Now, the only force that we're going to study is gravity. Gravity is what holds stars and planets together, and it depends on the mass of the objects. On Earth, gravity is known by many names: Earth's gravitational field strength, Earth's acceleration due to gravity, and they all are 9.8 meters per second. Gravity, however, is different on other stellar bodies, so due to their size. So gravity on the Sun is very different than gravity on Earth. The four forces that we're going to study are by type, abbreviation, direction, and cause. So be sure you get this slide written down very carefully. So the first one is tension. Tension is abbreviated as FT. It can go horizontally or vertically, so essentially all four directions and angles. And it is contact with your object. Now, this does include buoyancy, pushes, pulls, hangs, and is caused by ropes, strings, chains, people, and even other objects can cause tension. The next one is gravity. Gravity is Fg. It is always pointing down, and the cause is whatever stellar body that you're on. For us, 99% of the time, it's going to be Earth. Friction is the next one. It is FF. It always goes opposite of the motion. So if an object is going down, friction will go up. It will cause an object to slow down, and this does include air resistance. And the cause of that friction is generally the surface or whatever you're in contact with, especially if it's in the air. Finally, you have a normal force. This is Fn, also known as the support force. This is the force that is with any object that is on any surface, and it comes up from underneath. Normal is perpendicular to the surface, and the cause of the normal force is the surface. Examples of forces and their effects. So force of tension, again, is push, pull, grip, squeeze, right? It's also that buoyant force. It's also the buoyant force when you have something floating in the air. It's also the pressure, air or water pressure behind, like you have a hole in a cup, okay? It's also tension, right? Force of tension is what is a string or a wire, anything that is hanging. Then you have the force of gravity. Gravity pulls all objects down towards the center of the Earth, or whatever stellar body you're on. Gravity is also what holds the flying pig in position and what holds stars and planets together. FF is the force of friction. You can have high friction, rough surfaces, or low friction like ice. You can also have air friction or aerodynamics, air resistance. Okay, and I realize that tension in the air and friction in the air can kind of get a little confusing. Remember that friction makes objects slow down. Tension, it's just hanging there. And then you have the normal or support force. This is the normal force. It's the force that's always with you or any object on a surface. It is normal to put your books on the table and have them stay there. So let's look at analyzing and drawing force diagrams. To analyze any picture that you get and draw the force diagram, you have to be able to draw a picture or have one given to you. Identify the object of interest, because I'm going to be giving you pictures with more than one object. So be sure you're drawing the force diagram for the correct object. Sometimes it's best to draw a circle around your object so you can see those contact points. Identify any of the four forces that you have: normal, tension, gravity, and friction. Draw the directional force diagram, that's just the arrows, and then complete that force notation. And that force notation is force type on by. The by is the agent, or what the cause of the force. The on is the receiver or your object, and believe it or not, the effect is the arrow that you draw. So for example, gravity causes things to go down, and it comes from the earth. So look at this very quickly. If you were given a picture of a flamingo standing on one leg, to draw its force diagram, you might draw a circle around it, identify that we're looking at just the flamingo, identify that there's one touch, it's standing on a surface, so you would have a normal force. It's not moving, so you have no friction, and nothing is pushing or pulling it, so you have no tension, but you do have gravity because gravity is everywhere. So the base diagram would be Fn going up and Fg going down. This one, the sled, this is going to be like on every test that I ever give you. Notice again that you have a defined system of the sled itself. That's all you're going to look at. If we were to put people and presents in the sled, we would still be looking at the sled itself. You have some contact. You have two forms of contact, right? Notice those. So contact with the ground is your normal force. Contact with the rope is your tension force. And if this thing is being pulled, you will have a friction force that goes opposite the motion. And again, we always have gravity. So this base force diagram would be the force of normal going up, force of tension going diagonal to the right, force of friction going to the left, and the force of gravity going down. Let's get a little more detailed. If you had the boy on the slide, you would have the force of gravity going down, force of normal going perpendicular to the surface, and the force of friction going up the slide. Believe it or not, the boy doesn't float, so the boy there is a little bit of friction between his jeans or his shorts and the slide. So we would draw this force diagram to be the force of normal on the boy by the slide, the force of friction on the boy by the slide, and the force of gravity on the boy by the earth. This one, if you have a block sitting on a table, right? Look for and identify the forces acting on the object. Well, again, if you go through your list of gravity, tension, normal, and friction, gravity is everywhere, right? You don't have tension because nothing is pushing or pulling it. You don't have friction because it is not moving, or doesn't really want to move because it's a flat surface. But you do have a normal force. So draw those force arrows from a dot, label the arrowheads. So if you start with a dot, single dot in the middle, you have a downward force and an upward force. Those are the two that we identified. The downward force would be labeled Fg, block earth, and the upward force would be labeled Fn, block table. You're going to be doing a lot of these for homework. Thanks for watching.